Hello everyone. Okay, welcome back to our math class with me, Eka Putri, as your math teacher today. Now, how are you today? I hope you are all doing good, okay? Okay. In this session, we will discuss about sequence and series. So make sure you are ready to learn this topic. Okay, now our first topic is sequence. Now, what is sequence? Now, a sequence is an ordered list of number following a specific rule. Now, each number in a sequence is called a term. The order in which terms are arranged is crucial as each term has a specific position, often denoted as A sub n. What? A sub n, where n indicates the position in the sequence. Okay. For example, we have the sequence of 2, 5, 8, 11, and 14. Now, here each term is 3 more than the previous term. And also we have 3, 6, 12, 24, and 48. Now, here each term is 2 times of the preceding term. And we also have a 0, 1, 1, 2, 3, 5, and so on. Now, here each term is sum of two preceding terms. Okay? Are you understand? Okay, I hope you are understand. Okay. Now, the first topic in sequence is arithmetic sequence. An arithmetic sequence is defined as a sequence of number in which the difference between one term and the next term remains constant. Okay. Now you can see in this picture. Okay, the above image has a common difference of 2. Okay. In arithmetic sequence, we have the general formula to find the nth term of an arithmetic sequence is A sub n equals A plus n minus 1 times D, where A sub n is n terms, A is first term, D is common difference, n is term number. Okay, so, okay. And I also have a solve problem example for the arithmetic sequence. Now, find the 20th term of the arithmetic sequence 3, 5, 7, 9, and 11. Now, and we get the solution. Now, given 3, 5, 7, 9, and 11, and we know the first term or A is 3. So, and common difference or D is 5 5 minus 3, and we get 2. Okay, then n is 20 because this is a 20. Okay, thus A sub n is A plus n minus 1 times D, and then A sub 20 equals 3 plus 20 minus 1 times 2, and then we get A sub 20 is 41. Okay, here 20 term is 41. Okay. Nah, okay. So we also have a geometric sequence. Now, what is geometric sequence? Geometric sequence is a sequence of numbers where each term after the first is found by multiplying the previous term by a constant called common ratio. In the arithmetic sequence, we have a common difference, and in geometric sequence, we have a common ratio. Okay, in this picture, the above image has a common ratio of 2. This is for example of geometric sequence. Okay, now, okay, general terms are n terms of a geometric sequence: a times r to the power 2, a times r to the power 3, and so on, is given by a sub n equals a times r to the power n minus 1, where a is first term, a sub n is the n term, R is the common ratio where R not equal to 0. Okay, you can remember it. Remember this. And N is the position of the term in the sequence. Okay, are you understand? Okay. Okay. For the geometric sequence, I also have a solve problem example. If 3, 9, and 27 and so on is the geometric sequence, then find its ninth term. Okay, now nth term of geometric sequence is given by a sum n equals 8 times r to the power n minus 1. Given geometric sequence is 3, 9, and 20, 27, and so on. Here A is 3 and R is 9/3 and equals 3. Okay, therefore A sub 9 is 3 times 3 to the power 9 minus 1. So we have this. Okay? Okay. Now I think this is easy for you. Okay. Then we also have the topic of harmonic sequence. Now, what is harmonic sequence? Harmonic sequence is defined as a sequence of real numbers obtained by taking the reciprocals of an arithmetic projection that includes or zero. Now, in this projection, its term is calculated as the harmonic mean of its two adjacent terms. Okay, you can see this example. Now, if the arithmetic sequence is represented by the terms a plus d, a plus 2 times d, a plus 3 times d, and so on, then the corresponding terms in the harmonic sequence are 1 over a, 1 over a plus d, 1 over a plus 2 times d, and so on, and so forth up to 1 over a plus and minus 1 times d. Okay? So in harmonic sequence, we also have general formula. Okay? And the general term, or we can call a sub n or n term of the harmonic sequence, is given by the formula a sub n equals 1 over a plus n minus 1 times d, where a represents the initial term of the harmonic sequence. D stands for the common difference between successive term, and n denoted the total number of terms in the harmonic sequence. Okay, this is a solved problem example for the harmonic sequence. Determine the 12th term of the harmonic projection if the fifth term is 1 over 16 and the eighth term is 1 over 25. And we get the solution. Given the fifth term is 1 over a plus d. A plus d is 16. Okay, so 1 over a plus 4d is 1 over 16, and the a term is 1 over a plus 7 times d, and we get 1 over 25. Now, comparing this with the general harmonic sequence formula, we have 1 plus 4 times d is 16, and a plus 7 times d is 25. Now, by solving for a and d, we find that a is 4 and d is 3. Now, the 12th term of the harmonic sequence is 1 over a plus 11 times d, and so we get 1 over 4 plus 11 times 3, and so we get 1 over 37. Therefore, the 12th term of the harmonic sequence is 1 over 37. Okay, are you understand? I hope so. Okay, so next, the last topic in the sequence, we have Fibonacci numbers now. Fibonacci numbers are a sequence of numbers where each term of the sequence is formed by adding its preceding two numbers, and the first two terms of the sequence are 0 and 1. Now, as the first term, f sub 0, and the second term, f sub 1 of the Fibonacci sequence are 0 and 1. So the third term will be f sub 2 equals f sub 1 plus f sub 0, and we get 1 plus 0 equals 1. Okay. Now, as the first term, f sub 0, and the second term, f sub 1 of the Fibonacci sequence are 0 and 1. The third term will be, okay, this, okay. Now, similarly, okay, the fourth term is f sub 3 equals f sub 1 plus f sub 2, f sub 2 plus f sub 1, and we get 1 plus 1 is 2. Okay, and so on. F sub 5 is f sub 4 plus f sub 3, and we get 3 plus 2, so we get 5. Okay, this is the Fibonacci numbers. Okay, therefore the n plus 1 terms of the Fibonacci sequence can be expressed as f sub n is f sub n minus 1 plus f sub n minus 2. Okay, the number of Fibonacci sequence are given as 0, 1, 1, 2, 3, 5, 8, and so on. Okay. Yeah, the next topic is series. Okay, what is series? Okay, a series is defined as the sum of terms of a sequence where the order of the terms typically matters. Now, series can be classified into finite and infinite. Okay, depending on whether the underlying sequence has a finite or infinite number of terms. Example for the finite series is 1 plus 3 plus 5 plus 7 and plus 9. And for the infinite series is 1 plus 3 plus 5 plus 7 and so on. Okay. First topic in series is arithmetic series. Nah, the sum of term of an arithmetic sequence is called an arithmetic series. Now, suppose the first term of arithmetic series is A and the common difference is D, then the sum of the n term of the arithmetic series is given using the formula S sub n is n over 2 times A plus n minus 1 times D. Okay, if the common difference of the arithmetic series is not given by the last term of, say, the series is given, we say L. Now, then its sum is calculated as S sub n is n over 2 times A plus L. Now, for the example, now a tree fruits 5 apples in the first year, and at each successive year it has 2 more apples than the last year. Find the total apple for 3 bears at the end of 6 years. We get the solution. We know that apple bear by 3 in first year, or we call A is 5. Now, yearly increase in apple bear by the 3, we call D is 2. Okay, the time period, we know 6 years. The total apple at the end of 6 years in the tree. So S sub n is n over 2 times A plus n minus 1 times D. Then as so okay, this is as sub as sub 6 equals equals 6 over 2 times 2 times 5 plus 6 minus 1 times 2, and we get we get s sub s sub 6 is uh, 60. Okay, this is wrong. I think this is 6. Okay. Okay. So this is the total number of apples the tree bears at the end of 6 years is 60 apples. Okay, the next topic is geometric series. The sum of term of a geometric sequence is called an geometric series. The geometric series formula for the finite series is given as S sub n is a times 1 minus r to the power n over 1 times 1 minus r if r is less than 1. And so if r is greater than 1, we use a sub n equals a times r to the power n minus 1 over r times 1. Okay, where s sub n is sum up to n term, a is first term, and r is common ratio. Okay, for the geometric series formula, okay, we have as infinity is a over 1 minus r, where r is greater than minus 1 and r is less than 1. Okay, for the example, find the sum of geometric sequence 1, 2, 4, 8, and 16. Okay, given geometric sequence is 1, 2, 4, 8, and 16. We have the first term is 1. The common ratio r is 1 over 2 over 1, and we get 2 because 2 is greater than 1. Okay, the sum of geometric sequence for r is greater than 1 is given by this. So we get as sub 5 is 1 times 2 to the power 5 minus 1 over 2 minus 1, and then in the last we get 31. Okay. Okay, and in the last I also have some problem for you. Okay, you can try to solve this problem at home. I hope you can try for correct. Okay. 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 Okay, that's all our today's lessons. Okay, I hope all of you understand for the topic. And so, thank you for your attention. So, see you in the next lessons. Bye.